We're here for problem 1218. In this case, it's dealing with the cost of rising healthcare, and the researchers undertook a survey to find out if there was differences in healthcare expenditures that exist between men and women. So the survey randomly sampled men and women aged 21, 22, 65, etc. to determine the amount spent on healthcare. And the question we're trying to answer is, do these data allow us to infer that men and women spend different amounts on healthcare? So we've got in column A what men spent, what women spent, and we're looking at the difference. Is the difference equal to 0, meaning men and women spend the same amount, or are they different and it's not equal to 0? So this is what that third kind of inference. The first two were about differences between independent samples, and this is an inference about the difference between matched pairs. So the first thing we need to do is calculate the difference between men and women. So I'm just going to put difference right there. I'm going to go equal to the men minus the women, which gives us a calculation there. And I'm just going to drag by the fill handle to copy that formula all the way down. And now what I want to do is calculate the t score for alpha of 0.025 and degrees of freedom of 44. So equals t, it's 0.025, comma, to enter the degrees of freedom parameter. And then, in this case, the t inverse of 1 minus 0.025 with 44 degrees of freedom. So in this case, the rejection reason would be greater than the minus 2.015 or greater than the 2.015. You can also see it on table 4 on page 311. In that case, it would be for the t of 0.025 and degrees of freedom of 45, because the degrees of freedom run from like 40 to 45. So using this function is a little more precise, but for the most part that other way would give you an accurate answer as well. And so now what we're going to do is we're going to calculate the mean for the difference, that x bar d. So equals the average function, and then we're going to click here on C2 and go down to C46, close the parentheses, and we get an x bar of minus 42.943. Then we're going to do the standard deviation of the difference. So equal to ST, it's the standard deviation of the sample here. And again, I'm just going to click and drag. Go back up here, close the parentheses, and that gives us 317.1586. The end for the difference is the 45. And now we can calculate the t-score, or the t-statistic. So in this case, it's going to be equal to F14 minus UD, which was 0, and we want to take that whole amount, the numerator, and divide it by the SD divided by the square root of ND. And just 1 second. And I have an error in the formula. Here it is. I should have put that all in parentheses. And there we go. It's negative 0.91. And since negative 0.91 is not in the rejection region, remember the rejection region would be less than the minus 2.015, there is not enough evidence in this case to infer that men and women spend different amounts on health care. Again, so we have to summarize for this, with a matched pair you have to create a separate column where you just do a subtraction, and then you do the X-bar calculation, the standard deviation calculation, and calculate the n, the number of sample for it. And then you use all that information to calculate a t-score right here using this formula and compare it to the t that you would expect given the alpha and the degrees of freedom, and then see, does the t you calculated down here fall within the rejection region or not? And if it's not within the rejection region, then you have to conclude that there's not enough information to infer that there's the difference. That's it for 1218.